So there are three forms that we're going to focus on for our quadratic functions. We've been working a lot with the standard form. However, there's also vertex form and factored form. And seeing our function in vertex form and factored form gives us different pieces of information. So let's just look at standard form and kind of talk about those key pieces that we keep looking for and how do we see that come through in the standard form. So something we've talked about is the parabola opening up or downward, which is coming from our value for a, which is right there. So this has a equals -1. So with that, we can see a and quickly see that it's opening downward. So we have that piece of information. If I wanted to find the vertex, then I could use my x equals -b over 2a, and then I could find y by looking at f of that value. So a little work to do there, but we can compute it. For the y-intercept, we would look at f of 0. Actually, we can see the y-intercept pretty easily here, because when you're in standard form, that ax squared and bx will disappear when you plug in 0. So really your y-intercept is your value for c. So we'd have this point 0, -16. And then our x-intercept. So this is where we look at 0 equals f of x and then we solve. So we would have some work to do here. We could use factoring or quadratic formula to get to our answers for the x-intercept. So punchline to standard form is we can see the general shape, we can compute the vertex, and with the y-intercept we can actually grab that pretty easily without computation. And then the x-intercept would have a little bit of work to do. So let's look at the vertex form. And these, I just want to make sure I'm saying this correctly. Yes, so these forms that we're seeing here are all the same function. So these all make the same parabola. We're just seeing different pieces in these different forms here. But it's a little hard to see in this vertex form, but like if we factored out our x minus 2 times x minus 8, you can see we get our 16 and 10 and so on and so forth. But vertex form, we'd get that same piece if we FOILed out the x minus 5 squared and then combined like terms with that plus 9. But having it in this form tells us a lot. Now for a, we can actually see a right out front here. This is showing us that a is a -1, which is the same as before. So with this, we can see clearly that it is opening downward. Now for the vertex here, there's a reason that it's called the vertex form, and that's because it's showing us what our vertex is. It's showing us with this number next to x and this number adding or subtracting outside. Now for grabbing the vertex from vertex form, where I'm seeing -5 there, what we do, and this is similar to what we did with the absolute value functions, is that we switch the sign. So even though I see -5, the x-coordinate is going to be +5. So we switch the sign there, but then for y it stays exactly the same. So what I see from this is a vertex of +5, +9. Now for the y-intercept, we can calculate that pretty easily just by plugging in 0. For the x-intercept, we can calculate that by looking at 0 equals g of x, or g of x equals 0. Now when we solve our quadratic equation in this vertex form, when we plug in 0 there, what can be pretty nice, and we'll go through an example with this, is we end up using the square root method, which tends to be a little bit easier than factoring. So we'll see how there's kind of a different or a specific way of solving our quadratic equations when we have this vertex form. So punchline to vertex form is we can see the shape, we can find our vertex without any calculations. Y-intercept and x-intercept, we have to calculate a bit, just like with standard form. All right, with factored form. So in terms of shape, out here is our value for a. So we see our a equals -1 out there. So with that, we get the general shape. So really with all of these forms, We can see A very clearly and determine whether it's opening upward or downward. Now, to get the vertex from this form is a little tricky. What we would have to do is multiply everything out. So we would have to simplify first, and we would simplify to standard form. So you'd FOIL, simplify, and then basically get into standard form, and then you could use that x equals negative b over 2a. There are some shortcuts here to getting the vertex, but we're going to kind of skip that. But once you get comfortable with these, you might notice a theme with them, where if you know your x-intercepts, the vertex should be halfway between those x-intercepts. So that could be something you use, but we won't focus too much on that. Alright, y-intercept isn't too bad to calculate because it's just a matter of plugging in 0. Now the x-intercepts, that's what this factored form helps out with. So the idea is that we plug in 0 for h of x, and then what we would have to do in these other forms is then factor, but it's already factored. So if I plug in 0 over here, I would have x minus 2 equals 0, or x minus 8 equals 0. So x is 2, x is 8. So I'd get my two coordinates really quickly for the x-intercepts. So that's the value of the factored form, is seeing your x-intercepts of the graph. And the punchline is that you have x minus something, then you'll see the positive. And if it was x plus 8, you would see negative 8. So what you could do is, without even doing the solving steps, is just get your coordinates directly from those factored pieces. Alright, so that's where we have these three different forms. They all have their different value to them, and if we start making our quadratic functions based on a graph that's given to us, it might be that based on different pieces we're seeing, we'll want to use different forms. But in the end, they're all the same quadratic function. This standard form is, it's standard for a reason. It's because in that form, everything is simplified out, everything is multiplied, all like terms are added together. So we typically write things in the standard form, but it's that we can organize pieces in this vertex form or factored form to simplify. So here's kind of a summary of what we just talked about. So we have our standard form, the factored form, where you can see your x-intercepts. So I'm going to specify that as x-intercepts. Vertex form, where you get the vertex using h and k, and just again emphasizing that we expect subtraction to be there. So if you see minus h, you'll have positive h there. If it was plus h, you would have a negative number there. Alright, so for each of these, let's find the vertex, and then we're going to determine the domain and range. So these are both in vertex form, so we don't really have to do any math for it. So since I see minus 6 there, I'll have positive 6 for x, minus 10, minus 10. Now, finding domain and range. What I need, and some of you might be able to just think about this and have it, but I like to draw a little sketch. So my sketch would go, it's opening downward because of that negative out front. So it's opening downward, and then I have this vertex at 6, negative 10. So what this means is I just kind of visualize going 1, 2, 3, 4, 5, 6, and then I'm not going to count all the way down to 10, but somewhere way down there, this is just a sketch, I'll have my vertex, and then it's opening downward. So in terms of domain, with a quadratic function, the domain is always all real numbers. We can plug in absolutely anything. So that's done. It's the range that I need to focus on here. And what I could make note of for the range is that, well, it ends at negative 10, and then my function's defined off to negative infinity. So the range is going to use your vertex, and either it'll treat it as a maximum or it will treat it as a minimum. It just depends on the direction of your graph. So because it's going downward, that negative 10 is our maximum y value. So we can have everything from negative infinity up to and including the negative 10. So with domain and range with these, just think of a sketch, or you can think of that idea of minimum, maximum, and that'll define your range. All right, with this one, for the vertex, we'll have, so since we see x plus 5, it'll be minus 5 for the x coordinate, and then plus 1 will give us a positive 1 for the y coordinate. Domain and range. So domain I can already answer as negative infinity to positive infinity since it's quadratic. And for the range, what I'm going to do is think of a graph. So this one's opening upward, so my vertex is giving me a minimum value, but just to visualize it, like we'll be at negative 5, positive 1, and we'll have a parabola like this. So for my range, the minimum value is that positive 1, and then it goes off to positive infinity. So it starts at 1 and including 1, and then goes off to positive infinity. All right, our last piece here, it's going to be really quick. It's just forming the functions using the vertex in A. So I have a little typo here with the given value of A in the vertex. So my general form for vertex is f of x equals A times x minus h squared plus k. So what I'm doing is I'm plugging in the value for A, and then I'm plugging in the vertex. So my function will be called f of x equals, we'll have A, and then we'll have x, and then because it's a negative 4, we'll write that as plus 4. And then these are quadratic, so be sure to have the square in there. If you leave out the square, it turns into linear, so that square is very important. And then positive 7 for y, so we'll have positive 7. And then that's done. Over here, we'll have a of negative 4, and then x. Now, because the x coordinate is positive 3, we'll write that as minus 3, and then squared. And then the negative 5 will be a minus 5 at the end. So there's our quadratic function and some different forms that we can work with.